Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. My guest is Dayan Goodenowe. He's the founder, president, and CEO of Prodrome Sciences. And we're going to talk about his work and what are called, I hope I can pronounce this, Plasmalogens and longevity. So thank you for coming.
Thank you so much for having me, Richard. I really appreciate being here.
Yeah, tell me a bit about your background and what is Prodrome about?
Well, thank you. Yeah, so my background is in chemistry. My first degree is in synthetic organic chemistry. And my PhD is in psychiatric medicine, looking at the biochemical basis of psychiatric disease. And so I've been heavily involved in both the pharmaceutical and biotechnology industry for many, many years. And at the end of around 1999, I invented a technology called non-targeted metabolomics. And this allowed me to look at thousands and thousands of small molecules, basically the metabolic intermediates of all of our biochemical pathways in biological systems, such as your serum, your blood, tissue samples, genetically modified organisms, and so on. And the purpose of this was to be able to have a complementary technology to full genome chip technology, for example, where people are looking at gene expression analysis. And one of the main reasons for inventing and developing the technology was to understand functional genomics. When we're doing gain of function, loss of function, mutations, can we identify what these genes are really doing by measuring changes in their metabolic profiles after that happens? And we needed a comprehensive technology to do that. And so that's where that invention came in. And then as I applied it to more of the clinical research field, which is where the bulk of my work is, using, tens of thousands of patients around the world looking at different biochemical changes associated with disease, it was very successful at understanding the biochemical differences, like for cancers and neurological diseases.
Quick question here. How do you get a baseline, though? So, do you do metabolomics on a certain, let's say a mouse, and then you try to knock out one of its genes and then look at the changed metabolomics? Like, how do you establish what's changed?
Well, in the preclinical research, that's exactly right. So it's all in your experimental design at the preclinical side. In the human world, we use distribution analysis with just general healthy people or non-disease versus disease. So the different clinical phenotypes would identify the different variable classes. And so whether it's colon cancer pre, post surgery, age matched, gender controls, so to speak. So, and then we look at the effect of age, gender, disease states on biochemical profiles as a function of changes in individuals' variables. And that was very, very successful in multiple diseases. So many patents, developed other diagnostic technologies in relating to disease diagnostics. And so we sell like colon cancer and pancreatic cancer blood tests in Japan, for example. And so but what happened as I got more involved in this, one molecule class that came of many was called plasmalogens. These are critical phospholipids that are involved in neurological functions, synaptic release, They're involved in the amyloid formation pathway, for instance, as well as reverse cholesterol transport for cardiovascular disease. And they were lower in people with Alzheimer's disease. So that required more and more research and more significant research. And that's where plasmalogens really became a critical biomarker of disease.
What is a plasmalogen again?
So a plasmalogen is a membrane phospholipid. Okay, so your body, you can think of the human body like a massive apartment complex with trillions of cells. And what separates one cell from another is its biological membrane. So the human body fundamentally operates in a lipid matrix. Virtually all proteins are either directly or indirectly involved with the biological membrane. And a biological membrane is made of lipids, fats, phospholipids that create a phospholipid bilayer. And the membrane structure will modulate how well an ion channel works or how well a receptor works, as well as physically. Cells like neurons, they release neurotransmitters through a process of membrane fusion and release. So the neurotransmitters are stored in vesicles in the presynaptic neuron. And then when it gets a nerve impulse, the action potential pulse, that the vesicles translocate to the membrane, and they have to fuse with that membrane to release their components. That's all biophysical. That's the membrane structure is required for that. Plasmalogens are required for membrane fusion and release of neurotransmitters. And the interesting thing about plasmalogens is that your body must make them. We don't get them in our diet because the last step in their manufacture creates a very sensitive bond to acids and oxidative stress. So when you eat an animal product that contains plasmalogens, most of those plasmalogens get digested in the stomach and don't get into the blood supply. So your body's actually forced to make them. And you make lots of them. 20% of your brain is plasmalogen. We're not talking about trace level molecule. High levels in your heart, your lung, kidney, your eye. And children that are born with plasmalogen defects die.
So plasmalogens, this sounds somewhat like extracellular vesicles. I guess they assist in like the biogenesis of these vesicles that travel to the membrane and fuse, or do they exit cells as well?
No, they are in the membrane. They are part of the membrane. Physical. It's like part of your walls of your house, basically. They're actually, they are the walls of your house. Okay. So they're actually in that. And so if you can imagine if the walls of your house shrink or become unruly, like your doors don't open properly or your vents become restricted, so airflow changes and so on and so forth. And so
the plasmalogens are what, like the scaffolding of the lipid membrane of all cells?
Yes. And it's kind of a membrane modulator. So in neurons, the plasmalogens that contain a polyunsaturated fatty acid like DHA create high levels of fluidity and membrane fusion and protein activity. In your protective cells, like your oligodendrocytes, the white matter, or your Schwann cells in your periphery, like for ALS, there's an omega-9 plasmalogen, and that gives protection, creates a very protective impermeable sheath that protects the neuron from outside damage and actually allows the nerve impulse to travel long distances throughout the body. They're a major physical component of the human body.
What's where are they produced, by the way? How are they produced? Do you know?
Most of them are produced in your liver, but all the cells of your body can make plasmalogens, and they make them in an organelle called the peroxisome. And so you have two fatty acid metabolizing organelles in every cell of the body. One is the mitochondria, which is used primarily for energy generation. Carbon dioxide creates ATP, uses oxygen, converts oxygen into water, and that's the energy driver of the human body. The human body, I tell people, is like a series level electric car. We burn hydrocarbons, and we use the energy from burning hydrocarbons to charge a battery. And that battery is the electron transport chain in your mitochondria. And then that battery drives ATP. And that's what the body uses for energy all around. So that's fundamentally how the body, at the real core level, the body operates. And then in the functional capacity, it's all of our membranes, because that gives us our physical structure. So we're not just like a vat of soup, if you will. And so what our cellular structure is defined by our membrane compositions. And those membrane compositions can change with age and with disease. And one big one is this plasmalogen. It decreases with age for numerous reasons: liver disease, oxidative stress, reduced mobility, people aren't exercising enough. And this will translate into higher risk for Alzheimer's disease and higher risk of death. So plasmalogens are highly associated not only with Alzheimer's, but with all-cause mortality.
Well, quick question. If these are made primarily in the liver, though, do they exit the liver cells and then travel to the bloodstream to other cells and go into them and become their membranes? Or
before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
That's exactly how it works. So it gets transported on your membrane, your blood proteins like HDL and LDL and albumin. So it gets transported throughout the body in your blood. So you have 2 supplies. It's like cholesterol in a sense. Like your liver is a main manufacturer of cholesterol, but all the cells of your body also make its own cholesterol. And so there's 2 supply chains. Each cell can make a certain amount on demand, and then they have a secondary supply, which is from the blood supply, and then that's how it gets regulated. So if a cell makes too much plasmalogen, then they'll export it into the blood supply. If they don't make enough, they'll bring some in, and that's how every cell maintains its homeostasis of phospholipids.
Yeah. So what happens under various liver conditions like cirrhosis, or if you have to resect part of the liver, or if you have hepatitis, like what are the cascading effects? I would think there'll be tons of them.
It is. And especially like we talk about cognitive impairment, we think about cognitive impairment in the elderly, but we get cognitive impairment in younger people as well. Like women with breast cancer surgery, they'll have short-term cognitive issues. Liver disease will have cognitive impairment. And so we have issues in the younger populations due to adverse health consequences that result in reduced brain health. We just don't always characterize those people because we're not looking for that. And then they recover. So we say, okay, that's just a transient situation. So as we get older, though, that our ability to recover from those kind of insults becomes less and less. And so as I developed this technology and looked at other diseases, the concept came up of prodromes. So originally, we were looking at diagnosing disease. I was looking at using this technology to identify biomarkers that could differentiate someone with colon cancer versus someone who does not have colon cancer. And that's true. Those were very powerful biochemical differences between those groups of people. So we can diagnose diseases based upon their biochemical profiles. But what was surprising was that when we treated the disease, say for a cancer, where we removed the tumor, the biomarkers didn't come back to normal. Some did, but not all of them. And so we ended up showing that there was 2 groups of biomarkers. There was the symptomatic biomarkers, and then there were prodromal biomarkers. Biomarkers or of systems that were impaired or dysfunctional prior to disease, that were the disease-causing system. And plasmalogens was one of those disease-causing systems. So low levels of plasmalogens creates susceptibility to certain diseases. Alzheimer's and cognitive impairment is a major one. And so restoring plasmalogens and being able to fix low plasmalogens in individuals became a priority. So as a synthetic chemist, I designed biochemical intermediates, kind of like L-DOPA for Parkinson's. We developed plasmalogen precursors that would survive the digestion, get absorbed, and then get converted into the final plasmalogens. And then that can be done. And then when we tested these things, we found they were extremely neuroprotective. Like we can completely prevent demyelination in MS models, completely prevent neurodegeneration in Parkinson's models, and improve function. And so now we're using those in the clinical trials in humans, and it's available for anyone now as well for plasmalogen restoration and augmentation.
This sounds like it would affect any experiment you do in a dish with cells, any organoid, anything. I mean, if plasmalogens have to be replenished at a certain rate in a cell population, I mean, again, all those experiments in a dish where things just, we know the environment's not the same as in the body. Maybe if we add in plasmalogens to all these systems we use to study cells, they might make them more robust and work better and be closer to reality.
It does in certain situations, for sure. Now, your body actually has the capacity of making quite a few of these things. So you make a lot of them and you consume a lot of them. And that's why it's really associated with, people, virtually all cancers have low plasmalogens, and due to certain issues of cancer biology. People with schizophrenia have low plasmalogens. Alzheimer's, definitely big one. Parkinson's, ALS, these neurological diseases have pre-existing plasmalogen defects. And so that creates a susceptibility for those diseases. And long-term decline. And so what happens then is that our body's ability to make them becomes less than the body's need and demand for them.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
And at some point in time, if that mass balance gets in the wrong direction, you start bleeding out your plasmalogen reserves. Like your brain has lots of them. And so what happens is they get depleted with age and they get depleted with disease because the reserve capacity that you have when you're young, when you're making more than you need and your cells are flush with all the plasmalogens that they need and they can make them on demand. If we get increased inflammation, increased oxidative stress, increased liver dysfunction accumulating with age, at some point in time, our demand and need for them exceeds our supply. And at that point in time, we start getting depletions. And so those depletions show up in the blood work. And those depletions, depending upon how long that depletion has been there, will correlate with your risk of getting Alzheimer's disease. And so that's kind of where Prodrome came in, because plasmalogens are a real critical molecule. Like, so low level, you don't want low plasmalogens. It's just like the longevity difference is huge. Like, so a 65-year-old with low plasmalogens has the same probability of dying in the next 5 years as a 95-year-old with high plasmalogens. So a 95-year-old with high plasmalogens has the same life expectancy as a 65-year-old with low plasmalogens. They're serious. Like you don't want low plasmalogens. Then it's also involved in not just the elderly and death, your neuromuscular junction that controls muscle building, muscle memory, for instance, reserve capacity, inflammation. So these things, the human body is fairly interconnected. And so as I study more and more of this, we found more and more biochemical systems defective with different diseases. And we're starting to move our way up the causation pathway from, primary, secondary, tertiary effects of disease. So often when we measure a disease state, we're watching something that's been going on for a while. And so there's usually a lot of things messed up, at the late stage of a disease. And so you still have to treat those symptoms, like our traditional medical, if you have a cancer, you need cancer therapy and surgery and so on. And so you can't, you need conventional medicine to deal with conventional disease outcomes. And we're very, very good at that. Our current medical system is pretty good at preventing death. Like we've improved average lifespan. We haven't improved maximum lifespan because we're just preventing diseases, or we're preventing diseases from killing us. We're not fixing some of these underlying conditions. And so that's where Prodrome Sciences comes in, where we're looking at disease not as the focus of our attention, but we look at disease as educational. So Alzheimer's is an educational experience relating to what can happen if you don't have plasmalogen reserve capacity, for example. And so you want to make sure you identify where the human body needs excess capacity, and you want to have resilience and reserve capacity. It's the same way we exercise. So you work out. So if I run 5 miles every week, okay, it's not because I have to run 5 miles every week, but for the 6 days that I'm not running, okay, I'm only working out, 100 meters here and there. I'm just idling. Okay. So we exercise to create excess reserve capacity. So if you work out with weights and you can lift X number of pounds, well, it's not because you have to do that every day. It's because when you don't work out, now when you're doing your everyday life and I'm lifting up my pencil and I'm working on my mouse, okay, my body is humming along at a really fundamentally under capacity. It's like, and it's kind of almost like economics, where you want to live beneath your means. Okay, I want to have a lifestyle that's significantly less than my expenditures are significantly less than my income, so I don't have to worry about my next paycheck. And we can do that biochemically, where we basically say, okay, let's create biochemical reserve capacity in advance. And we use disease as an educational tool to identify where the weaknesses, where are the more likely things that will occur with age that we want to make sure we get a handle of in advance. That's rather than waiting for the disease to occur and to fix those systems afterwards, we can fix them in advance. Like if you're sitting in a castle and the enemy is coming, I don't have to wait for them to breach the walls. I know which parts of the wall I want secured.
What's the thought to make sure the liver is functioning optimally to diagnose what's going on? Is that the primary way to ensure you have the right level of plasmalogens if you're low?
Correct. And it's not just, plasmalogens are a critically important part of your biological systems, but they're not the only thing. Okay, we want to make sure your methyltransferase system, your cholesterol regulation, other biomarkers that are important, your omega-3 to omega-6 ratios. So make sure that you're not choline deficient, because that's another big issue in our world. So plasmalogens are absolutely a critical component to health and longevity. But the human body is biochemically designed to work. Okay, it works. And it has optimal windows for everything. And there's certain windows that you can have a little more than needed. Like you don't wait for rickets to happen before you take your vitamin D supplement, for example, right? Or you don't wait for scurvy to get vitamin C in your diet. So there's things that we understand logically for many, many different parameters. And so biochemical blood testing, so we have a test called Prodrome Scan, and it measures basically all the key core biochemical systems, including plasmalogens. And we can fix all of them. We can restore plasmalogens, we can restore methyltransferase activity, we can restore mitochondrial function. And depending upon the individual, you can target those biochemical systems into their optimal operating windows. Plasmalogens, like I said, are critical. And that's where the book called Breaking Alzheimer's deals with, 15 years of research on this topic, large clinical trial work that we're doing. And so that's kind of what Prodrome Sciences is all about. And to teach people that your biochemistry is you, it's alive. Okay, you have control over these biochemical markers and you can modify them. Diet, lifestyle, current supplements, not just the plasmalogen supplements that we have created, because that's a unique case, because there was no plasmalogen supplementation before I was able to invent and develop and design these molecules, which we should have had decades ago, but we have them now, so that's good to have them. But that's kind of what Prodrome Sciences is all about, and that's what kind of my research is about teaching people biochemistry, fixing it 1% at a time. Alzheimer's is a big deal. Parkinson's, we have a lot of people in Parkinson's that we work with. Multiple sclerosis. I've written extensively on autism and the mitochondrial defects of autism. But fundamentally, it's biochemical health.
How do you fix this then? Like, what's the protocol that, what's the angle you're taking on how people can fix it once they understand their biochemistry?
Well, for example, if you have low cholesterol, for example, so we have an obsession with trying to get cholesterol low, but the optimal level of total cholesterol in the human body is somewhere between 220 and 250. Okay, nobody should have low total cholesterol over 200, and no one should have total cholesterol under 200. If you have cholesterol levels under 200, that means you have basically cellular sickness or liver sickness, and that could be due to a choline deficiency. So simple phosphatidylcholine supplements can fix those issues. If you have high fasting triglyceride, resistance training, plasmalogens actually help that. So plasmalogen supplementation can fix that. If you have oxidative stress issues with mitochondria and acetylcysteines, carnitines, alpha lipoic acids, so you can fix these biochemical systems with strategic biochemical intermediates. And that's kind of so we provide that level. We interact extensively with functional medicine doctors across the country. So we have hundreds of doctors that we work with that understand this, and we create this feedback mechanism twofold. One is the feedback on the blood testing, so people can physically see changes, like C-reactive protein. If you have C-reactive proteins over 1, there's no reason for that. Okay, you got to get your C-reactive proteins under 1, showing that your oxidative stress level is unacceptable. So there's ways of fixing that. And so these are things that people can fix and monitor. And once they find the right balance that they need, plasmalogens, certain supplements, certain diet, intermittent fasting, they create a lifestyle and diet and supplement strategy that optimizes their biochemical health, then they can relax a little bit, because you removed most of the boogeymen that can come and get you. Because disease isn't random. Disease occurs in the absence of function. Disease is not a protagonist. Diseases don't lurk and come after you. Diseases occur in the absence of function. If you have function, you can't have disease. Okay, it's only when you lose function that disease comes in. So disease is always opportunistic, and we give it way too much power. And so the goal for functional medicine and for longevity and for health is to understand where your biochemical deficiencies are and fix them in advance. Like, I don't need to know, right? Like, I don't need to wait for my engine to seize to know that I need oil in it. Like, I don't have to wait for an outcome to have certain things in their proper operating windows. And people have this sense of inevitability, or they have this sense of powerlessness that they don't, they're going to just walk down the street and some random, strike of lightning is going to afflict them. And it just doesn't work that way. All diseases have prodromes. Biochemical dysfunctions occur prior to disease. Okay. Now, obviously, if you get a severe enough insult, it can, even the healthiest people can get a disease, but that becomes very rare. And that's what we do.
Yeah. So what's the do people then, when they work with your company, do they get evaluated to look at their level of plasmalogens? Like,
Absolutely.
are there what biomarker tests would show
we
the
send
state of them?
That's what we do here, just down the hall from where I'm talking to you now. So the blood test, we send blood samples anywhere in the world, basically. They ship the blood samples to us. We do our advanced biochemical measurements here, provide a report on my website, drgoodenowe.com. There is detailed explanations of all these biochemical systems. We deal with functional medicine doctors extensively, so a lot of doctors use our services. And then based upon your blood work, you can get certain supplements to restore them. Some of them that we provide, you can get some from Amazon if you want. It's not, we're agnostic about that process. Plasmalogens are one that we provide for people that need them, and they can then get functional improvement from that. And that's kind of our strategy. We work with doctors, we work with individuals. Alzheimer's and cognitive impairment and athletic performance are the areas that we focus on. MS, Parkinson's, and so on.
You said you supply them, so exogenous plasmalogens. What does that look like?
It comes in a bottle with oil. Basically, it's oil. It's like olive oil. Basically, it's an oil. You can take it. I take mine in the morning with my cup of coffee. And so you just
delicious plasmalogen latte.
Exactly. It's so it's a pure supplement. So that's what we do here. It's all I'm kind of human biochemical engineering. We don't get involved in too many fancy supplements relating to a bunch of different natural health or plant extracts, which some are very, very helpful. And that's just not our area. We deal with pure supplements that.
Just thought it'd be funny if you were known as Babyface Goodenowe, because you took so many plasmalogens, you had beautiful skin.
Yeah. It's been helpful for me personally. I'm 52. I've been on them for a few years.
Hey, what have you observed? What did you observe when you started? What about now?
My first one, biggest issue was eyesight. I used to have progressives. I can't wear progressives anymore. My short-term vision has come back. I was always nearsighted, so I had glasses for driving, and then I needed progressive because I was having more difficulty reading. And then a few months after taking supplements, the plasmalogens, I don't need my reading glasses anymore. I can't, anything within a 4-foot radius, I don't need glasses, or even really short. Wow. Then I don't get headaches anymore at night because I work on a computer a lot. And so I used to get a lot of that fuzzy, headachy feeling that I never get anymore. And I've always been kind of a moderate athlete, not an extreme athlete, but physically I'm stronger than I've ever been in my 20s. I do more push-ups. My recovery time is faster. And these are things that I've been athletic and then not athletic enough. Work out for a while, then maybe take a year or two where I've been just too busy to do much exercise. And I finally get fed up and said, okay, I'm going to start working out again. And I realized, okay, I know from previous experience that this is going to hurt at the beginning. I'm going to have muscle pain. I didn't have any of that this time. My recovery time was faster. And so I can do push-ups. Normally I would do 30 push-ups when I was younger, I do 3 sets of 30. I do 50 push-ups and I rest for a minute and I can do another 50. The second set, I can do just as many as the first set. And it's just weird with no muscle pain. And so those are things to me personally. Most people that more elderly, with cognitive impairment, they notice improvement in focus and cognition. People can feel better, more awareness. And so that's what we see. We had some pretty dramatic results in Parkinson's. So it's real. It's a molecule that goes right into your neurons, neuromuscular junction for me, of course, retinal function. But we're dealing with fundamentally the elderly population as our number one priority is improving cognitive cognition. And that's what the book Breaking Alzheimer's is about, is for people to understand that these are restorable systems. And then in the younger groups, like women with multiple sclerosis and children with autism, we've got a lot of experience with that now, reducing neural inflammation. And we have a omega-9 plasmalogen called Prodrome Glia, and that's designed for white matter tracts. And it's for calming the neurons down. And we've had some pretty good results in autism on that. So basically that's what we do,
That's
biochemical engineering, and with real people. We educate people on their biochemistry, teach them that they shouldn't be afraid of it. They should embrace it. They can move it. And then also that they should not just intellectually feel better, they should emotionally and physically notice a difference, because people should feel better. And people, healthy is the default. Okay. Like you should be healthy. Okay. Like we shouldn't accept disease. There's no reason to accept it. And so that's kind of what we kind of breaking. Alzheimer's is also about breaking a bunch of misconceptions about the disease, about the pathology. We look at disease late in the stage of the game, and science has a very bad habit of giving causation to symptomatic. The classic example is this Alzheimer's amyloid drug, come out. It's a classic situation where here's a symptom of brain dysfunction. Okay, clearly amyloid in the brain is not good. You shouldn't have it, right? Like no one's going to say, "Yay, I got amyloid in the brain." Okay, that's idiotic. So obviously, but the question is, it's not you have amyloid in the brain, what amyloid is doing. The question is why does your brain have amyloid in it? Like that we're asking the wrong questions. What is it in the brain that stopped working that caused amyloid to accumulate? It just didn't appear out of nowhere. It like the first two laws of thermodynamics still apply. It's not. So we have to understand where it comes from, and where it comes from is plasmalogen defects. So people who have high levels of plasmalogens in their brain, we did this post-mortem, have low levels of amyloid. Okay, and so the amyloid precursor protein, which is metabolized, it's metabolized by one of two enzymes. One enzyme does not cause amyloid plaques. It's called alpha secretase, and that enzyme is higher in people that have high plasmalogens in their brain. The bad enzyme is called beta secretase, and that's in a different part of your cell membrane, and that occurs when you have low levels of plasmalogens. And so these are the underlying reasons for the amyloid deposition issue in Alzheimer's disease. But medicine is about that. Medicine is about, there's traditional medicine, which is important. Okay. Like when you get in a car accident, you have a tumor, you want the best possible treatment capabilities of that actual symptom that you're experiencing. Okay. To prevent you from dying tomorrow, you need that level of acute care. And we're really good at that. Our medical community has done an incredibly good job, and it's evidenced by our improvement in average lifespan. So less people die of disease now than ever before. And that's because we are good at treating disease. We are not very good at treating underlying causes of disease. And it's not designed. Like I think people in the functional medicine, they like to kind of blame the medical community for this. That's not their job. We need a different group of people focused on that. They're complementary to each other, not antagonistic to each other. And so it's a big world with a lot of things that get done, and nobody can do everything. And so I think that's kind of but the problem is that we've got a lack of balance. We don't have enough real work being done on this prevention side. And that is hard work. It takes larger studies. It takes proving that something doesn't happen. So Breaking Alzheimer's discusses that in detail at the end of the book, actual real strategies at how we improve community health through, outreach and actually physical hands-on work. That's what we do here. It's not a theoretical job.
So what are the steps by which someone, so all right, where can people go to find out more? And then what's the process that they'll go through when they contact you?
So you can go to drgoodenowe.com or prodrome.com. Our products are available to anybody. You can get the advanced blood testing is still only available through doctors. So we can set you up with the functional medicine doctor and get your blood work done. But supplements and everything else are available to anybody. And we have a simplified plasmalogen blood test that just got launched this week that anyone can get their plasmalogen test measured. You don't need a doctor for that. But for the advanced blood testing, we have a certification for doctors that we train doctors. Doctors are our frontline people that deal with patients. Our goal is to interface with the functional medicine doctors, help them continue doing the work that they're doing and add to their repertoire of fixes for people. And then also for awareness to everyday people that, there are solutions out there that people can access and take advantage of. So
people can go and do they have to do the test in order to be able to use the oils and supplements or no?
No. If you have symptomology or if you're into athletics or if you can just start. There's basic protocols that work for anybody. I had my dad on it for years before, we did all the blood testing work. So you can get, anytime. And that's the other thing.
Okay.
We all take our own products, everyone in our company and our families. And so this stuff is very real to us.
Well, last question. So you told me about your experience, which is great. What are some other anecdotes that you've heard from customers? Maybe like, I don't know, common ones or surprising ones or amazing ones?
Yeah, well, okay. So I got one function. We're going to, in August, part of our physician roundtable, Dr. Mitch Fleischer out of Virginia, runs a functional medicine facility there. He's had a couple of really dramatic recoveries in Parkinson's. He had 2 patients, one that was immobile, wheelchair, ended up doing escalating dose. Eventually, the person is now walking. The person's wife sent him a video of her husband shoveling snow. So we have had large levels of improvement in cognition. The clinical trial we just finished in Santa Monica. Person with a clinical dementia rating scale of 3 has come down to a CDR of 1. Like that's late stage Alzheimer's to mild Alzheimer's, okay, in 3 months. Like these are severe improvements. And so that's in the medical part, but people themselves with their parent, they'll notice just improved mobility. And there's little things in our everyday life that we notice when we're caring for someone, and we all have parents that we care for. You'll notice things like they're getting up more. They don't sit down as much. They play with the grandchildren. All of a sudden they're fixing something in the house that they hadn't fixed forever because they feel that they can do it. And they don't notice these differences, right? Because it's little things in your everyday life that you're reverting back to more normal. And it's hard to recognize that in yourself sometimes. And things take a little while before you can see that. But then all of a sudden, people around you notice these improvements. And that's what people are experiencing. We commonly see people tell we have improved sleep is a big one. People sleep better. They're less anxiety. Because remember, plasmalogens are the number one neurological system that it improves is the cholinergic system, which is related to cognition. Synaptic function is important for all neuron types, not just your cholinergic neurons, your GABA neurons and your serotonergic neurons and so on. So depending upon the underlying issue that a person has, there are other neurological improvements that people can experience. So that's why some people say, I have less anxiety. I have the head of our manufacturing, his son has autism, and he's takes Prodrome Glia, and they've had dramatic improvements in his son's interaction with themselves and with people in their environment. So these are things that are doable, right? It's
that's great.
It's so that's kind of what we see. And obviously Alzheimer's, cognitive impairment is a key issue. Other areas that I'm focused on, especially multiple sclerosis and Parkinson's and those other neurodegenerative diseases are key. Those are the things that we need to fix first and start working on those.
Okay, well, very good. Dan, the best way for people to engage is to go again to what? Can you repeat the URL?
Yeah, go to drgoodenowe.com or prodrome.com, and there are solutions for everybody. So you can either go direct yourself, or we can potentially hook you up with a doctor in your area that uses our systems and products. And then there's lots of education. I have a doctor certification program that I teach doctors about the biochemical mechanisms of different diseases. But there's also an educational seminar series that's free to everybody. And it talks about different biomarkers in the blood, different diseases, different philosophical issues. And they're pretty in-depth science, but hopefully understandable to everybody. But people can choose how deep they want to get into things, but ultimately it's designed to be accessible to everybody.
Okay. Well, Dan, thank you for coming. It's been an interesting podcast, and I appreciate it.
You're very welcome. Thank you for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.